Okay, let me reiterate. This is all optional. Um, as I was writing this on the board, I was trying to think. I wonder how many people will watch this. I'm thinking 10 per section. We'll start it, and 8 of you are already gone. 8 have already quit. Maybe 2 per section. If I get one person to follow me through this, I'll be excited. Why am I doing it? It interests me. This is from I assigned, and I've said this at the end of the last video, and I've said this hopefully in class over and over. Assigned a couple of 3 things across the term that are optional, that are a little more developed, require a lot more mathematical ability or background. Ability is the wrong word. Background is the correct word. And this is one. This is a blog post that from earlier in the summer from a fellow by the name of John Miles White. John Miles White is a Princeton PhD student, or let me say, he was a Princeton PhD student in psychology when I saw his blog post. I don't follow him or anything. I was just looking at Twitter, and I follow various statisticians and so forth. Somebody had posted a link to this blog post and said it was neat. It's actually more than neat. It's probably the beginning of something really fundamental on the backside. It's about means, medians, and modes. He doesn't say anything about dispersion, but dispersion measures. The last ones that we looked at were range, average deviation, and variance standard deviation. I'll explain these going forward. I'm translating his notation into mine, his notation into our problem in our data set, the one such as it is, that's on the board that we've referenced numerous times. He's really presenting a unifying perspective for understanding mode, median, mean, average deviation, standard deviation, or variance, and something else that has to do with the mode, a measure of dispersion that has to do with the mode. That's what he's invented here, which is really neat. I had known not my entire life, I've known for more than half of my adult life that the mean minimizes the variance, and that the median minimizes the absolute deviation. So, no, average deviation. Known that for forever. There's some calculus involved. We don't have to even go to the calculus here, and we won't. I'll use a term that is calculus related, but I'm trying to illustrate it. Because we only have 10 observations, I think I can illustrate it sort of in person, no calculus, right? So, first things first, John Miles tells us we're going to have to believe in the non-standard idea that the absolute value of 0 raised to the power of 0 is equal to 0. And I think he over-defends himself here. I don't think I've ever seen the absolute value of 0 before some calculation or whatever. Before raising to the power 0 to the power of 0, there is a very standard argument in mathematics that would have the absolute value. Well, it would have anything, any positive, any integer raised to the power of 0 would be equal to 1. And I can illustrate that fairly easily, and I'm going to. There's another couple of mechanisms whereby one can reason that in this particular case, the 0, as opposed to any other number raised to 0, can't equal 0. And he should have latched on to that, I think, and just embraced it. Anything including 0 raised to 0 needs to equal 1 for a number of mathematical proofs that are quite important, at least for their elegance, but it doesn't really matter so much for... Long story short, there is a very substantial rationale to say what he says, that raising 0, the absolute value of 0, to the power of 0 is going to give 0. That's key to his argument about the mode, right? Now, on the other hand, everything else raised to the power of 0 equals 1. And I'm going to kind of illustrate that for those of you who don't, right off the top of your head, know theory of exponents. I've got the number 3 here, and at the base, raised to the power of 1, that's an identity. 3 to the power of 1 is 3. Probably you already knew that. Guessing you already knew that if you squared 3, you'd get 9. 3 times 3 is 9. And guessing also you already knew that 3 cubed is 27. 3 times 3 times 3. Or alternatively, importantly, 3 times 9 is 27. So probably you never noticed, but when you do exponentiation like this, you're using one fundamental thing. You're multiplying numbers. And of course, just as we can go the other way and divide numbers and ask the question, from 27, which is the cube of 3, how do I get the square of 3? And the answer is really simple. To get the square of 3, you divide 27 by 3, right? And you get 9, the square of 3. And to get back to unity, to get back here, how do I get from the square of 3 to 3? And this could be any number realized. Since we started with 3, it could be 5, 1,749,000, doesn't matter. How do I get from the square of something back to whatever it was that I squared? And the answer is divide by that something. And we're going to do it here again. It's 3. So how do I get then to the 0th power? Is that a word? 0th? Raised to something raised to the power of 0. Also divide by 3. So you divide 3 by 3 and you get 1, which is 3 raised to the power of 0. 3 is 3 raised to the power of 1, 9, and so on. The net result here is any in his design, any on the modal situation, any number. We're going to use the test score over here. So our x sub I is, once I said test sub I. I'm going to use the test scores here as an illustration of what he's come up with, sort of unifying theme. And gonna look right here. Look at this. I'm going to briefly. So we're going to have CT stands for central tendency. On John Miles' blog, he's used the term S. We used S in the standard way. So didn't want to do that. So there's sort of a central tendency. Three different alternatives. One is subscript 0, one is subscript 1, and one is subscript 2. 3 alternative measures of central tendency we're going to talk about related to the variable test, x sub I. And these are just things we've already seen. They're the summation sum. You're summing across n. In our case, n is 10. Summing across n, and a little different than we saw in the earlier video. In every case, I'm taking the absolute value here, and in the 3 different cases, in one case I'm going to raise it to the 0 power, in the other raise it to the 1, and the other raise it to the 2nd power squared. This term means in mathematics the argument of the minimum, and what it means in the little subscript underneath it means argument of minimum of CT. So it's asking what makes this sum as small as it can possibly be. What number for CT makes this sum as small as it can possibly be? We're doing the same thing across all 3 of these, to the 0 power, to the 1st, and to the 2nd, the squared one. So this is simply, you don't have to know calculus at all. You don't have to know calculus. We're asking for what value of CT makes this expression a minimum. John Miles doesn't even include n, but n is trivial here. It's a constant. It's going to go out every time. It's just dividing it by 10. So we're going to focus on the sum, and this first thing, raising elements of this vector to the 0th power. Once we do the difference, take the absolute difference and raise it to the 0th power, given his rules here. Okay. Now let's go over here to, look, I'm going to make, hopefully, I'm going to convince you that any number that I put in here for CT, any number that I put in for CT, other than one that appears in the vector, is going to produce in here in the numerator the number 1 for this very reason. See, so everything other than 0 raised to the 0's power is equal to 1. So a number that's not up here is 45, right? 71 minus 45, 91 minus 45, 72 minus 45, 85 minus 45, any one of those, every single one of them, when placed here, so the number 45, it's just going to be a sum of ones. Can you see that? So if I put any number in here, other than one that's an observed value in the vector, anything, then the answer to CT0 is always going to be 1 plus 1 plus 1 plus 1 10 times. 1 plus 1 plus 1 plus 1 plus 1, 1, 1, 1, 1, 1, 10 times divided by 10. The answer is always going to be 1. Always. Now, alternatively, if I put a unique number meaning one that appears over here only once, what I'm going to get for that particular calculation is a 0 and a 1 for all the others. So let's say I choose as a possibility for CT the number 100. Well then, as you look inside here, raised into 0, I'm going to be some 1 plus 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 0 equal to 9 divided by n, which is 10. I'm going to get 0.9. So I'm looking for the minimum that I can possibly get in the sum. That's what I'm looking for. That's what an algorithm would be looking for, right? And we found something that's better than putting in a number that's unique and not in the vector. That is to choose an observation that actually exists. But that's not the minimum. The argument of the minimum is looking for the lowest score you can possibly get. It's looking for the value for CT that will minimize the sum. And then we'll divide it by n. In the answer, and I mentioned that last time, this variable has a mode. And the mode is 71. 71 is the mode definitionally, right? Because it's the category that has the most observations. There are 2 observations of 71. So if I choose 71 here, now what I get is I get 0 plus 1 plus 1, 1, 1, 1, 1, 1, 0 plus 1. So I have 8 divided by 10, 0.8. John Miles White here has found a brand new measure of dispersion. This thing here is the mode. In his piece, he makes the point in idea 2 that a ratio level or continuous variable like this can have more than one mode, and in that case, you get more than one correct answer. But that's neither here nor there. This is really neat stuff because we continue then on to here and find, I've already mentioned this, that instead of CT0 being the mode, so raise this to 1, now we've got 71 minus the average deviation. And lastly, this thing here, I had n minus 1. We'll just go ahead and put that there. It doesn't matter because what would minimize this over n and what would minimize this over n minus 1 would be the same up here, given this statement. This then is the variance. Now, whereas the mode, these things are. I don't know what to call this. Whereas the mode minimizes this expression, the median will give you a minimum here every time. And whereas the median minimizes that one. That is, by minimize I mean gives you the smallest possible number after the sum of any possible alternative. So plug in anything here but the median when you're looking at just the absolute difference. Anything other than the median will give you a larger number for CT1 than will the median. And for here, the answer is the mean. Absolute magic. Clever, unifying. Where it goes from here, I'm not sure, but it shows. I mentioned in the earlier video that these things are deeply related, and my thought process when I've taught that and thought that all along has been related to probability distributions and things like moments of probability distributions. He's given us maybe a different unifying perspective. He's in psychology, as I mentioned, at Princeton, or was very recently, and brings a perspective and a background, deep background in machine learning and computer programming languages. And so his thought process sort of integrated with basic stat training and produced a unifying perspective across mode, median, and mean that gives us the variance of the average deviation and some clever, new, incredible thing up here that I'm not so sure of. If you followed all this, I will buy you a beer at least when you turn 21. Thanks.